So I wanted to begin by thanking Mona for inviting me to this conference. I'm sorry I can't attend in person. I'd love to have been there, and I'm also sorry this is not a live presentation. I've had to record this, but whilst you're watching this, it's actually 1 a.m. my time, which is US Mountain Standard Time, so I'll be fast asleep. So again, two apologies there, but I hope everyone enjoys the conference. I am going to be talking for the next 20 minutes or so about geospatial and GIS. I am going to be thinking and talking about the fact that I believe that the geospatial industry is at a tipping point, and that there are some key drivers behind why the industry is at a tipping point, artificial intelligence being one of those. And that's how I'm going to finish this talk. And that should be a good handoff to Mona for what she's going to be talking to you about. So my name's Matt Sheehan. You can tell from my accent that I'm British. I'm actually now based in the US. As I mentioned, I'm in the mountain state, so I actually live very close to skiing in Salt Lake City, Utah, which I'm told is very, very similar to Tehran. So one day I'd like to visit, as I've mentioned. I came over here, I did a physical geography degree in England, and then came here to do a master's degree in the 90s in GIS. I didn't know what GIS was when I first arrived over here, but two things caught my attention when I got to the US. First of all, I saw the internet, and this was the very early days of where they were testing the internet. It's actually the US military had built out what was called the ARPANET, and there were a few universities that were on that network. So I saw that for the first time. And I also saw this thing called GIS, which was this complicated desktop application. And for those maybe they have my hairline, I'm for sure a few of you do in the audience. Then there was a desktop product called ArcView, and that was one of the earliest, probably the earliest Esri desktop product. There was ArcInfo, and then there was ArcView, and ArcView was a sort of a easy to use application. It morphed into ArcMap, and now we've got ArcGIS Pro. So I learned GIS in my graduate degree. I was taught, again, what you guys are probably learning, how to work with software that's desktop based. But my interest was really on this emerging world of web GIS. So I decided, against my professor's wishes, actually, to do to write a web GIS application. And that was very early into the game where the internet was very new. It was in the mid 90s. And luckily for me, Esri had released a product called Map Objects IMS. So I was able to actually leverage that product with some programming skills that I had to actually write a web application, a web GIS application, which was used by the Forest Service. So that's a good segue into what I'll start this talk about. And that's really the history of the industry. I think it's important we understand where we've come from, particularly as I suspect many of you are students of geospatial and GIS, and then to bring us up to the present. So let's just go on a little journey within that world. So my time at starting in the geospatial industry, again, was at that transition period where we were moving from a pure desktop-based world to the addition of web technology. So we moved into this distributed world where we could actually build applications and have them accessible by people everywhere. So the applications that I wrote when I was doing my graduate degree were available to, if you had an internet connection in Iran, you could have seen those applications. So very different sort of paradigm shift from the world of the desktop computer to this web-based computing system where you could actually share maps, and you could share, more widely some of the access to that data. So, and let me just say, for those that are maybe new to this, the word geospatial means place on Earth, and I use that a lot when I talk about our emerging world, because I think GIS has been this sort of go-to umbrella term. Primarily, it's an Esri terminology now. I think Esri now kind of own the GIS space. Geospatial's broader than that, and we'll cover that in this talk. So, but we're really talking about data that has a locational component to it. So what were we working with when the web emerged and desktop? We were working really with two-dimensional maps. That's ultimately what the data was that we had available to us. And I was at that time writing programs ArcIMS programs, that kind of technology. Again, for those that are older will remember that. Those of you don't, it's good that you don't, because that technology was very early and the user experience wasn't great. But hey, we were advancing and things were moving forward. So a lot of the GIS world has been built and based around two-dimensional data. And again, I remember back to my classes where we were really focused on points, lines, and polygons. And I always got that confused in my mind when I first started looking at that. But ultimately, that's kind of how the data is stored in a geodatabase. Now, open source was available at that time. Esri was quite dominant in that when I started working in early 2000s, late 90s. And Esri have grown, and I think, again, a lot of you will probably be Esri users and know that technology. So that kind of set the stage for the evolution, really, of the world of GIS. One of the biggest things that happened in the mid-2000s was the emergence of Google Maps. And that was quite a transformation. Why was that? Because they created, amongst other things, the access to a wide variety of data. So you could actually access base maps, imagery-based maps, and vector-based maps, etc. That it wasn't a widely accessible world before Google Maps. It was still sort of locked into organizations. Then we all had access to maps, which was amazing, and web maps. And the other thing that was interesting about that period was we had slippy maps as well. So slippy maps, for those that don't know, because we take it for granted now, are where you actually pan and zoom in a seamless way. Back in the day with ArcIMS, whenever you panned or zoomed, the image flashed. So a message was sent to the server, send me back a new image, and a new image was generated, and then you saw it. So it flashed and flashed and flashed. It wasn't a great experience. With Google Maps, it became a really seamless, easy experience. So it was an important evolution. And actually, Esri themselves were quite scared about what that meant, because at that time, Google were actually suggesting they were going to get into the commercial market. They went away from that and stayed focused on the consumer marketplace. But for a little while there, Esri were a little bit concerned. So we had this new web technology now. Desktop hadn't gone away. Analysts were still being taught at universities how to do very clever things with geospatial data on the desktop, as they are today. But we had this new world where you could actually bring non-expert users into that world of GIS via web technology. So let's get to the end of the 2000s, around 2008, 2009. The first iPhone appeared. Very small screen, but a mobile computer. For me, and I actually started a company out at that time, I saw the first iPad, so the first big screened mobile device. And the thing that really caught my attention in a geospatial way was this device had GPS built into it. So I had a mobile computer which knew where it was. That to me was groundbreaking, and I set up a mobile development company to actually take advantage of that. And you've seen the revolution since then, that everyone's now got a computer in their pocket that's more powerful than the technology that sent people to the moon in the 70s. So crazy advances in technology. But mobile was another milestone in the evolution of geospatial. So we went from desktop to web to mobile. And we heard a lot at that time about how many apps were built that had a locational component to them, how many games had a locational component to it. So it really put on the map, if you'll excuse the pun, location-based data. And again, it was still a sort of a two-dimensional world there, but we were all driving around getting directions from our phones as we do today. So again, that was a really big advance. I think from an organizational perspective, and I realize this is a sort of an energy-based conference that I'm talking to here, infrastructure. I'll call it infrastructure. What the mobile revolution meant, and adoption within the infrastructure world was slow, as usually technology is. It meant that we had GIS departments in utility companies, etc., and they were generating maps, web maps for people to use across the organization. So GIS wasn't just locked into the GIS department any longer. There was beginning to be able to share this location-based data out across the organization. And we know that infrastructure, the world of infrastructure, is basically a geospatial business. I mean, if you're in utilities, you've got pipes, you've got different buildings that are those pipes are going into, those power lines, etc. So you've got a real infrastructure that can be seen and organized and analyzed using location-based data. So So that was where we had got to in sort of the mid 2010 was beyond. We had mobile technology. We were internet access, and people in the infrastructure businesses were beginning to adopt that technology. The biggest thing about mobile was that people were actually able to use maps in the field. So field workers who were, and we'll talk a bit more about this in a minute, veg management, they were able to go out in the field and actually see where they needed to go to, what needed to be done in the field, and they could report back into the office. So location technology was begun to be used to help folks in the field. And anyone that knows ArcGIS Collector will know the Esri technology, which that was the earliest, most popular mobile GIS application at the time, and that has grown, I know, into a different product mix now. So about 5 or 6 years ago, we began to see another change in what I really call the third phase of this evolution of geospatial. We started to see the miniaturization of sensors. So that means that, and we're beginning now to talk about remote sensing, and I'll define that in a second, but we began to build hardware devices which were small that could collect data. So that wasn't just cameras, that was a whole plethora of other sensors. And IoT is another part of that world, which again we'll touch on. So remote sensing has traditionally been around for a long, long time, and it used to be about photogrammetry primarily. It used to be about taking photographs and processing photographs, and quite often that was photographs that were taken from aeroplanes, from above, sometimes from satellites, and we would process those images, and then we would produce data products from those images and use the images themselves. So that was sort of the journey, that's where the journey with remote sensing began around photogrammetry. But because of this revolution that we're experiencing today, or we're still in the midst of, the ability now to collect data from different places through different sensors has really expanded. So when we talk about remote sensing, it means we're sensing, we're like a camera. We're taking a picture from a distance. We're collecting data from a distance and then using that data and processing it to generate something else. So the world of remote sensing has really exploded, and it's been a massive, it's had a big it's having a big impact on geospatial. So I actually work now within an organization called NV5, which is primarily a remote sensing company. And so the work that we do is based around putting sensors into fixed-wing aeroplanes, into helicopters, into drones, into vehicles driving along the ground, and people that are stationary on the ground. So we collect lots of different types of data from different places. The type of data we collect include images, include LiDAR. There's a lot of conversation around LiDAR these days. Again, LiDAR is a technology that goes back a long, long time. But we've really sort of perfected that technology, and we've miniaturized the sensors that can collect data using that technology. So what is LiDAR? LiDAR is actually laser. So it's a spinning device which sends out lasers, and those lasers bounce off a surface and come back. So what the technology can do is a hardware and software. It can actually know the X, Y, and Z of that point that's bounced off of that wall or that building or that whatever it's bounced off of. And when you've got millions of those beams coming out, you know the X, Y, and Z of the area that it's collecting data from. So if it's an aeroplane, it's flying over a transmission line, and it's sending data down and bouncing it back to the aeroplane and collecting all that data. So what does that mean? It means you can actually construct, amongst other things, three-dimensional worlds from that. So again, if you know the X, Y, Z of a point, you can combine all those points together in something called a point cloud, and you can get a 3D representation of what you're looking at. And there's a lot of conversations around the value of LiDAR from planes and drones and helicopters. It's resolution's a big thing. There's a whole world that you can jump into and start exploring, because I think that LiDAR is an ever more popular technology. But not only LiDAR can we talk about, we can talk about hyperspectral and multispectral data. Again, I'm no expert at the remote sensing world from a sort of the pure technology side of it, but the things that we can collect from but with multispectral and hyperspectral sensors is again, we'll talk about veg management since that's an area I work in within the utility world. We can know we can through analytics, we can process that data and come up with if a tree is healthy or unhealthy, what species of tree we've got. And that's an important question for utilities, since for transmission folks, they need to know what's a threat to that transmission line. They don't want outages, and they certainly don't want wildfires as a result of a tree coming down and falling on that transmission line. So that kind of data is incredibly valuable. There's other data that we can collect, which we won't go into here. There's thermal data where we can actually know if a device on a power pole, for example, is above a certain threshold in terms of temperature and may explode. So we can monitor that and report back and take action on that. There's one other technology I thought worth mentioning, and that's bathymetric LiDAR, which allows us to punch through water and actually see what's underneath the water and map out the what's underneath the water. And that's really important in the world of flooding. It's also important close to shore if we try and map out for ports, for example, what the shape of the surface under the water is close to the shore. So lots of these technologies. So what's the important piece that I haven't mentioned yet? What we're now doing is moving from a manual process of data collection, and I'll go back to talking about ArcGIS Collector. That's a manual process of collecting. We take our phone out and we manually collect data. We pop a point on the map, and that's how we've just collected a pylon, for example, to an automated processing sequence, which is what really remote sensing is and what we're talking about here. So we can fly along a transmission line, we can collect LiDAR, we can collect all these different data sets, we can classify that data. So that means we can actually understand if that's a pylon, if it's not a pylon. We can do a whole slew of different things to actually sort of build intelligence into the data. We can also combine those data sets as well. So if we take a three-dimensional, we take a point cloud and we color that based on the health of the tree, for example, we can say that all orange trees are unhealthy and all green trees are healthy. And you can actually see that in 3D. So amazing things that you can do by processing and analyzing that data and combining those data sets. So there's a whole world of data products now that are being produced through remote sensing. There's also two-dimensional products that are generated from this as well. So you can take LiDAR and you can generate the polygon for the crown of a tree, and you can color that tree in orange to say that's an unhealthy tree. So you can bring this stuff into a two-dimensional GIS, for example, and view this from a two-dimensional way. Let's talk about one other thing which is emerging, but it's been much discussed, IoT, the Internet of Things. That's really where we have intelligent devices, but every device has its own location. So when we are streaming data from a feed of, again, something that's sitting on a generator, mapping, collecting data on its temperature and reporting back in real time. I mentioned it, if there's a problem with that generator, it is at a critical threshold temperature-wise, we're getting a real-time feed to say we should do something about that. So that's one part of the sort of the four-dimensional world of geospatial data. The other one is obviously movement, so people moving around, vehicles moving around. So IoT is not just sort of stationary devices, it's also in cars. So you'll see, or in vehicles, for example, in boats. So you can, from supply line, I know not power and energy, but in a supply line where you can track where a package is as it moves from China, for example, to the US. So there's always that going on. You can track things in warehouses. You can track people as well. So there are a lot of things are going on. So there's a two-dimensional world of geospatial, there's a three-dimensional world of geospatial, and then there's a four-dimensional world of geospatial, and they're all valuable. And I think where we're moving to is actually bringing those data sets together to help us solve problems. So the world of geospatial is no longer just about two-dimensional data as we've worked in GIS for a long time. It's now about in combination with three-dimensional data. So one can argue that the value of 2D is the where. Esri's statement is, or slogan is the science of where. So it's the where, it's patterns, it's relationships. So a lot of value in two-dimensional data. Three-dimensional data gives you a sense of place, as if you're standing there. So, and we can talk about digital reality. I'll touch on that in a little bit, but if we have a three-dimensional perspective, it's very different to a two-dimensional perspective, but it does stop us from needing to go out into the field potentially and do work in the field, because we've already got a three-dimensional version of this, which we can explore. If it's LiDAR, we can get centimeter accuracy if we do measurements. Four-dimensional data is about change. So if we want to watch change, and when we want to understand change and act on change, then that's the four-dimensional world. And we're moving now to a world in geospatial where it's the combination of 2D, 3D, and 4D, which is helping us solve problems. So that's a really hosepipe blast of the history of geospatial, where we've been, and where we are today. The one thing I've missed out is AI on purpose. So artificial intelligence and machine learning, that's the other piece which is driving this third revolution. So yes, we have a tsunami of new data, multidimensional data, impossible for us to analyze and process ourselves given the quantity of data. But with AI and machine learning, we can automate, and there's that key word, we can automate both the processing and analytics of that data. So again, I'll reference back to my organization. We have a team of experts that understand remote sensing data and are very focused in their particular parts of that world. Imagery folks, hyperspectrals folks, LiDAR folks. But we have the ability now to automate a chunk of the processing of that data before it gets to one of those experts. So AI is now being used to automate lots of what we're doing, lots of that work, and ever more of that work is being done by AI. Does it replace those guys? No, it doesn't replace those guys. It certainly replaces the lower level jobs in that world, but it automates that journey to arrive at a data product in our case, and then obviously software is used to ingest that data product and to allow us to access that data and make conclusions about things, bringing it into a desktop application, sharing it over the web, even putting it in a mobile device for someone in the field. So that's a massive change, that world of automation. And automation has been to date really a background process. So we've heard a lot about artificial intelligence, machine learning, but we as a sort of a population, so to speak, that aren't in that sort of data science world, we really haven't had access to that data, or at least we haven't really seen directly the benefits of AI. It's quietly ticking away in the background. In fact, AI is being used when you go and do searches and you do sort of your Google searches for, or whatever you use to do shopping, and you get recommendations that come up about what you should be looking at. There's AI in the background that's analyzing what you're working on and giving you those recommendations. So quietly, it's been sitting there for a long, long time. So what generative AI has done is to bring AI front and center into our faces. And I know Mona's going to talk about ChatGPT. I'll touch on that here and just give you some sort of early thoughts on how I see it. It was interesting. I actually did a post or wrote a post, some of you may have seen it, a few months ago on ChatGPT. And it was basically based around a conversation I'd been having with a group with a group of colleagues around what the potential of ChatGPT could be to the geospatial industry. And what I realized was that the opportunity for something like, and I'll use the term generative AI instead of ChatGPT, the opportunities for that to automate the geospatial journey is incredible, and we've only just touched on it. So let me just break down part of what I spoke about in the post that I put in, and it was a very, very popular post. I was quite amazed by how many people actually came and looked at it. ChatGPT is a text input-output solution whereby you type in a question, for example, ChatGPT will, in the background, search across a database of information and then come back with an answer. So it's got the intelligence to actually go out, understand the question, and then go out and try and find the right answer to the question. So it's only as good as the database is that it's using, and I think I've heard it's like a 2-year-old version of the web, or it's a set of different databases. But obviously, the answer you get back is only as good as the information that you're pulling that answer from. So would that work with geospatial? I'm thinking about a couple of scenarios. Let's talk about one that's a utility-based one that I've touched on already. I'm a veg manager at a utility, and I'm most concerned about transmission line. I want to know along that section of, say, let's say 5 miles of a transmission line, where I should be cutting trees. So we could ask ChatGPT that question. Now, ChatGPT wouldn't, and you could try this. ChatGPT won't come out with a very good answer to that. Why? Because the data that it's going to be pulling from in terms of database is not there at the moment. So what a geospatial, a geo ChatGPT would need is access probably to what ChatGPT pulls from, and a geospatial database that provides answers to these questions. So in reality, how would an analyst who was using desktop software solve that particular problem? Well, they would have access to the right data. So that would be probably colored point clouds, probably hyperspectral data, a mix of data sets. So they would need access to all of that data. So number one is the data. Number two is the processing of that data to understand where those trees are in relation to that transmission line. If there's a 6-foot limit, if that's the threshold, then we need to know where along that section of transmission line are those sections of vegetation that are too close. We would also need to know which trees are a threat. Some that are unhealthy that are close to the power line, need to know about those. We would also need to know about the species of trees potentially. In the US, the east of the US, the aspen tree is threatened by a beetle. So a lot of them are dying. So if they're close to power lines, they're problematic. So you need the right data, you need the right analytical tools to actually analyze that data, that mixture of data, to come up with what I'm just describing here. And then you need the ability to actually have some kind of a viewer that was allowed you to view the output from that particular study, if you like, where you could see all of that data. And maybe that's a point cloud viewer in combination with a 2D viewer. That's one of the software products that I work with called Insight. So it has that combination. So think about that journey with a Geo ChatGPT. Number one, it would need to understand the question. That's first. And again, ChatGPT would not be able to answer that question. I sometimes use the example of a recipe, what are the ingredients? What are the instructions to get to that final pizza? So number one, we would need to be able to understand it. Number two, we would need to have the right data. And number three, we would need to have some kind of a software tool and visualization tool to process that data and allow people to access it. So that's not there at the moment. There isn't currently there. ChatGPT will likely never provide that. So my thinking is what we're going to be moving towards is sort of geo ChatGPT. I'll call it that, which are able to actually do all of the things I've just described, but against a database which has more information that ChatGPT can access at the minute, but also has geoprocessing capabilities in the background. So if I want to ask this question, and again, we're some way away from this, but if I ask that question about where I should cut down where the problematic vegetation is along that transmission line, the steps that need to be gone through for me to go from a text question, to an output where I jump from the question to the output, and I see a map, maybe I see a point cloud. We're a ways away from that, but that's kind of where we're moving to, where the analyst in the middle is being pulled out of the conversation. And I think that's a point, one of my parting points for this talk is, for those of you that are learning how to do the nuts and bolts of analytics in ArcGIS Pro, for example, more and more ArcGIS Pro will use AI, and it's using it now or QGIS. There's two of the most popular desktop GIS technologies. More and more, they're going to be using AI to help you get to your answer quicker for your analytics. Over time, long time, I don't think analytics is going to be analytics is mostly going to be done by AI. So we'll have generative AI where the questions are answered. We'll have the data and the processing all done through this automated process with an output. And you'll see on the web folks that are trying this with OpenStreetMap. I know some of the folks in Esri are trying it. So they're building against their existing APIs and outputting kind of quite simple maps. Show me all the coffee shops in Salt Lake City, for example. Very simple question, a very simple output. So we're going to get much more complicated over time. But I think that the opportunity is massive, and I believe that now we have access to all this data, and data is going to be a massive problem because we know there's the right data. An engineer wants a certain level of, as an example, an engineer wants a certain level of accuracy in data, which a GIS person doesn't. So centimeters over here, not centimeters over there. So it depends what the question is and what output someone expects. That's very nuanced, but it's complicated. So data is going to be a critical one. What type of data, how good that data is for answering the question, and then obviously accessing that data. Can a ChatGPT access all the data it needs to answer that question? And then do we have that automated geoprocessing engine within that can actually crunch all of that stuff and output things? So we're a ways off of it, but I think that the stakes in the ground, so to speak, about where we're going to with this. And again, I'll summarize really where I believe that we are, that yes, we are at a tipping point in the industry. Yes, I do believe that thanks to this new multidimensional geospatial data we're collecting and processing and analyzing, we've entered a new phase. So we've got new fuel. AI and machine learning are automating the process. Generative AIs are giving us a simple access point to answer questions. So where we're heading is fascinating. I think it's going to allow us to answer many more questions that we used to be able to answer in a much quicker way. I think we don't want to get too excited yet because we're quite a long way from this, but the stage is set for getting to that place. So I think that's probably a good point for me to stop talking. I hope this helped. I hope this is a good segue into what Mona's going to be talking about. I think, and I'm biased, I think if you're in geospatial or GIS, you've chosen the right field to be in. I think that it's a fascinating time to be in the industry, and I've seen it through 25 plus years, and now is the best time to be in it. It's changing rapidly, and you'll look at the big players in the market and how they're beginning to change what they're talking about and the products they're releasing. So we are in a bit of in a period of change. Keep your ears to the ground. Read as much as you can from those folks that you can trust. There's a lot of nonsense out there that is people talking about how wonderful their product is. Try and step away from that and take a bigger picture view on. And I try my hardest to do that myself. And what I write in LinkedIn and primarily is I try to sort of take that non-biased perspective, see which way the wind's blowing. But good luck to you all. I hope one day, like I said, I can come and visit you in Tehran. And Mona's promised me she'll give me and my wife and I a guided tour around. So I'll hold you to that, Mona. And I hope you all enjoy the conference. And it's nice to be with you, if remotely. Thanks very much.